Om Swastyastu. Assalamualaikum Warahmatullahi Wabarakatuh. Syallom, Namo Budaya, salam kebajikan untuk kita semua dan salam sejahtera ke kita semua. Let me introduce myself. My name is Putu Paramartha and my number code 2305531068 and lecturer Prof. Dr. Tjokorda Gde Tirta Nindhia, ST MT M Eng. Course Metalurgy, Mechanical Engineering, Technical Fakulty, Udayana University. Chapter 5, Modern Oil Production, and topic: effect of oil on solidification structure, melting furnace, molten metal processing, primary production casting, foundry casting, non-ferrous casting alloys, powder metallurgy. Modern alloy production. The manufacture of modern alloys is accomplished using a wide variety of melting, casting, and fabrication techniques. The selection of a specific manufacturing process depends on the alloy system under consideration, the form of the product to be manufactured, the condition in which it must be processed, and the properties that it must process in order to be as effectively in the intended application. Practical all of the commercial alloys products today are manufactured using melting and solidification technique that have been offered to product an acceptable level of quality in a cost-effective manner. This alloy production method may consist of traditional iron melting practice, vacuum melting method, or powder production technique. As of this process has its own set of advantages and limitations, and extension of as discussed in detail in the chapter. 1. Effect of alloying and solidification. The solidification of alloys is a complex process, and it is most easily understood by examining how the solidification characteristic of alloys differ from those of pure metals. Solidification of pure metals: when a pure metal begins to melt, the solid liquid mixture stay at the melting point temperature until all of the solid has completely melted. The amount of thermal energy needed to complete the transformation from solid to liquid in the function by the latent heat of fission material. 2. Solidification structures. The solid-liquid interface during solidification normally exhibits one of three types of crystal growth in the liquid: planar, plural, or dendritic growth, as known in fact. 4. The type of growth is controlled by the manner in which it is removed from the system. When the liquid ahead of the solid liquid interface has a positive temperature gradient, heat is removed from the liquid by condition called the going solid. thermal supercooling. Cooler road as infrared invite fight occurs when the advancing planar solid liquid in interface becomes unstable, and a small speed occurs on the interface that then grows into a cellular type structure. The planar surface becomes unstable because any part of the interface that grows ahead of the remainder enter the region in the liquid that is at a lower temperature. The intrinsic that form remain isolated at first because the global solidification. There is very latent heat of fusion into the ejectant liquid, causing a local increase in the temperature. Consequently, parallel speak of almost equal speaking advance into the liquid. 3. Melting furnace. A wide variety of furnace technologies are available for melting meat. In steak making, for example, pig iron is produced in a blast furnace from iron ore, limestone, and coke. Because it contains excessively high level of silicon, manganese, carbon, and other elements. This liquid iron, together with scrap and fusing agent, is then introduced into a basic oxygen furnace or an electric furnace for further refining with oxygen. The objective is to reduce the silicon, manganese, and carbon to acceptably or low level in the resulting steel. And for molten metal processing, molten metals are processed and handled in various ways depending on the alloy and melting practice that are used. Melting is a basic way of combining elements for the purpose of alloying, and the overall chemical composition of the molten alloy must be carefully controlled and processed before casting can take place. The resistivity of molten metal at high temperatures also requires special processing technique for removing or preventing the formation of inclusion, impurities, or dissolved gas in the melt. Fusing of molten metals is often the first step in obtaining a clean melt. Fusing is a term commonly used in produce and making the components that refers the molten metals fragments from the addition of a chemical compound or in gas. The various function of molten metals, fluxing at device, addressing or in combination, include 1. Removing enclosing impurities or dissolved gas from the melt. 2. Preventing excessive formation of solid phase inclusion. 3. Preventing and removing oxide of on furnace wall for injecting or distributing allowing constitution. 5. Primary production casting. The primary production of metal normally involves either ingot casting or continuous casting of products such as strip, sheet, wire, or bar. Continuous casting offers certain benefits over static casting, but not all metals can be continuously cast. Work products are typically cast in ingot form for substance working reduction operation, fabrication and finishing of metal product in the book. Foundries also request the use of ingots that can be remelted or sometimes hard-hit ingot to provide specification composition. 6. Foundry casting. Foundries as various method to cast parts with complex shape and interior surface. Molds are made in a variety of ways so that the modern metal brought into the mold CVT result in a part with the shape and dimension of the finished form. The cost of molding depends on several factors such as part size and shape, quantity, rolling, and the molten metal being poured into the mold. The casting method can be divided into 3 broad categories. 1. Casting with example mold. 2. Casting with real shape. 3. Casting with real shape or permanent. 7. Non-ferrous casting alloys. In terms of cast iron is the most common foundry alloy, consisting of approximately 3/4 of the worldwide production of casting. For example, the 40 old cast of wood casting production avoided the total worldwide production of casting in at metric tons. The amount of the cast alloys in that years was distributed among the various alloy system as follows. 8. Powder metallurgy. The development of powder metallurgy or again processing metal powder can be produced as a wide variant of mechanical methods as well by chemical and electronical methods. Automation is the domain method for producing metals and solid powder from aluminum, brass, iron, low alloy steel, stainless steel, tool steels, superalloy, titanium alloys, and many other important industrial alloys. Current automation technology is the result of steady advance over the last 70 years since the First large-scale production of atomic iron powder during World War. By the atomic powder had accounted for more than 60% by weight of all metal powder products in North America. Currently, it is method the Nation capacity of metal powder action metric tons per motion has become the dominant mode of powder production because its production that for economy of scale and because colored powder can only be produced by advancing technique. Thank you.